Okay, so we are going to start with inequalities and interval notation. So inequalities is the last section of chapter 2. And so what we want to look at first is we want to look at, well, inequalities. What are inequalities? So we have inequality symbols, right? Oh, wait. So we have a less than symbol. We have a greater than symbol. We have a less than or equal to. And then we have a greater than or equal to, okay? Now, it's important that we realize that when we're reading our inequalities, we should read them from left to right, just like you read words. That's how I know that this is the less than. You see, from left to right, the mouth is not open to the left side. So this is the less than symbol. For the next one, the mouth is open to the left side, so greater than, right? Then you have your or equal to, so you have the less than or equal to, right? So you basically have half of an equal sign underneath the less than symbol. And then the greater than or equal to, you have what? Half an equal sign underneath the greater than symbol. Math doesn't make it hard. It puts things right in your face. A less than or equal to symbol is a less than symbol with part of an equal sign, right? And so it's right there for you to understand it. So let's look at just an example. So how we've evolved. So when we have an equation, if we have something that says x is equal to 3, what does that really mean? Well, it means that if we were to look at it on a number line, it means x is actually 3. It means x cannot be anything else on that number line because the x is equal to 3. So when we do inequalities, we are introduced to something called interval notation because we are going to create an interval that shows us the actual values that are represented by the inequality statement. So, what if we have a statement that says x is less than 3? Well, what does that look like? So, when we have inequalities, one thing we want to do is we graph them. And we graph them so that we can then identify what are the values that are present in the solution. Because x equals to 3 is a solution. What does that mean? It means that 3 is a solution to the original equation. So when we have a solution that says x is less than 3, what does that mean? Well, we're going to visualize it. So when we draw it on a number line, x less than 3 means that x is going to represent any number that is smaller than 3. X is going to be anything that is less than 3. So when we identify the numbers that are less than 3, that would be the numbers to the left, correct? Because those are the numbers smaller. And so we just shade on the number line to just give us a visual representation of where is the solution located. Well, the solution is any number smaller than 3. So what's that mean? Well, 2 is a solution to this, right? Because 2 is less than 3. That's a true statement. A solution means any value that can create a true statement in the original problem, right? And so any number less than. So when you look at the notes, they show you open and closed circles. Well, what we're going to use is we're going to use parentheses and brackets. And what that's going to do is that's going to help us when we actually use it for interval notation. So I'm going to use a parenthesis here because x is just less than a 3. Okay? Now, if we had x less than or equal to 3, well, what does that look like? Well, on the number line, I'm just going to draw the 0 and the 3. Instead of a parenthesis, x can actually be equal to 3. So x can be any number smaller than 3, or x can actually be equal to 3. So when it can actually be equal to 3, we're going to use a bracket. Now, what you will see is for problems like this, if it's just like a less than, we would use what's called an open circle. When you have an or equal to on it, you would use what is called a closed circle. But what we do is we are evolving open circles mean parentheses. Closed circles mean brackets. So we use a bracket, okay? So let's look. If x is greater than 3, well, what does that look like on a number line? Well, x is greater than 3, so it's a parenthesis because there's no or equal to. And where are the numbers greater than 3? Well, in the other direction, right? Towards 4, 5, 6, 7, 8, right? Understand what it's saying. You know numbers that are greater than 3. Think about it. Don't just try to go through the problem to get it done. If you actually understand it, it'll make it easier for you to get through the problem, okay? And then x is greater than or equal to 3. So 0, 3. Well, greater than or equal to. So that tells us right away what? Bracket. And then we're going to shade towards the direction where the numbers are all larger or greater than 3. So anytime you have just a less than or just a greater than, what does that mean? It means you're just going to use parentheses. If you have a greater than or equal to or a less than or equal to, then you're going to have brackets on your problem. Okay, now let's look at these problems that we already did so that we can look at interval notation. So interval notation, basically what we're doing is we're creating an interval, okay? So when you do interval notation, your interval notation is going to go from your smallest value to your largest value. And I'm going to just put them in parentheses, but you're going to use parentheses or brackets depending on what your problem is looking like, right? So on this first example here, x is less than 3. Well, what does that look like? So you can use your real number line. So the real number line is what? Well, the real number line goes from negative infinity all the way to positive infinity. So the infinity symbol is just like a sideways 8. So from negative infinity to positive infinity, because it goes on forever and ever. You can't count all the numbers that exist. Okay, and so we just want to make sure that we understand that. So the 0 helps you separate what? The positive side from the negative side. So when we are looking at this x is less than 3, and we have this interval, we want to write this interval notation for the solution. So the interval notation, basically you're going to identify what is the smallest value present on this solution to the largest value present of this solution. So what is this arrow here telling me? This arrow is telling me that the smallest number that this x can be is going to be what? Negative infinity. There is no stipulation that tells me where to stop. It doesn't say it can't be smaller than something. It just says x is any value that is what? Less than 3. So that means the smallest value that is present on this solution would be negative infinity. And then from negative infinity to what? Well, what is the largest value present? Well, the largest value goes up to 3 with a parenthesis on it. So understand, we don't have time to list every single number, 2, 1, 0, and then there's decimals and small numbers in between there. So all we do, interval notation allows us to get an interval so that we can just have an understanding of, oh, the solution to this problem here is any number from negative infinity to 3. So I could pick any number between there. Negative 120 is a solution to this problem because negative 120 is what? Less than 3, and it creates a true statement. So anything that can create a true statement in that original problem is a solution to the problem, to the inequality. So therefore, that's what our interval notation is showing us. Any number between negative infinity and 3 is a solution to x is less than 3. So let's look at the next one. X is less than or equal to 3. So what is that? Well, that interval notation tells us what? The smallest value present would be negative infinity. The largest value would be 3 with a bracket. Because what? Because 3 is an actual solution to this problem. Because if you put 3 into the original problem, 3 is less than or equal to 3. That's a true statement. Whereas in the first one, if you put it in there, is 3 less than 3? That's not true. That's why 3 has a parenthesis and not a bracket. Okay? When you really understand it, it really helps you cut out the mistakes. Okay? Next, we have x is greater than 3. Okay, so what does that look like? Well, looking at my graph, the smallest value would be from 3 to what? To positive infinity. And understand, 3.01 is larger than 3. So that is part of the solution. That's why we actually have the 3 written, but we use a parenthesis because you don't know how small those numbers go. And so you go all the way to 3 without including 3. Okay, so from 3 without including 3 all the way to positive infinity. And what do we notice here? Regardless of the or equal to symbol, anytime you have an infinity, you will always use parentheses on your infinities. You will always use parentheses on your infinities. Parentheses, infinities are not a definitive value that you can actually touch or count. So therefore, we can't actually hold an infinity. So we can't put a bracket on an infinity because it's not something that we can actually take part in, right? So we always use a parenthesis because it's not something we can actually count. So then for the last one here, we have x is greater than or equal to 3. So what do you think that looks like in interval notation? So what it should look like is a bracket with 3, comma, to what? To positive infinity with a parenthesis on it. Okay? So interval notation. And if you use your interval notation straight from your graph, it makes everything easier. Okay? All right, let's look at another one. All right, so looking at these inequalities here, okay? So we know they're inequalities because they have inequality symbols. So when we look at these problems, let's number them. The first one says y is less than or equal to 4. So there's nothing for me to solve here because the variable component is actually already solved. So when you're doing inequalities, it's two things you have to do. When you solve it, you have to make sure you graph the inequality. So you're going to graph your solution, and then you write the solution in interval notation. Okay, so here we go. Y is less than or equal to 4. So I'm going to draw my number line. I just say write the 0 and then write whatever the value is. Like, you don't have to do all those tick marks and everything when you're doing it on your own paper. So y is less than or equal to. So less than or equal to tells me what? Bracket or parentheses. It tells me bracket. So less than, where are the values less than 4? Well, on the left side. So I'm going to put my bracket and open it to the direction of the solution, right? So my graph, this is my graph, and so my interval notation would be what? Well, from negative infinity to 4 with a bracket on it, right? Because where are these going? From negative infinity, smallest values, right? All the way up to the largest value, which would be that positive 4, and it has a bracket on it. Next, we have y is greater than negative 5. Okay, so mark your 0 so you always know your positive side from your negative side. Y is greater than. So there's no or equal to on this problem. What's that mean for me? It means I'm going to use a parenthesis. So y greater than, well, which direction are the numbers greater than negative 5? Well, they're facing the right. And so that means that's where I'm shading, right? That's where my solutions are. My solutions are to the right. So what is the interval notation that shows me the smallest value to the largest value for the answer? Well, parenthesis from negative 5 to what? What's the arrow tell you? It's going on and on to positive infinity. So any number between negative 5 and infinity is a solution to that statement. All right, and so then you have 3 and 4. X is greater than or equal to 10. x is less than negative 2. I think you should try those two by yourself and see how you do. So you should pause it and try those. Okay, so I've drawn the graphs for these two. So for number 3, we have x is greater than or equal to 10. So this should be your graph, right? You have a bracket on the 10, and then you're shading towards the positive infinities. So what is your interval notation? Bracket 10 to positive infinity. That's it. That's it. What does it say? It says that all values between 10 and infinity are a solution to this inequality statement, which is true. You could put anything between 10 and up in there and it'll be true. 10 is greater than or equal to 10. Yes. 11 is greater than or equal to 10. Yes. 12 is greater than or equal to 10. Yes. Right? All right. Number 4, x is less than negative 2. So this is our graph, right? This is our graph. So our interval notation should be from negative infinity to negative 2 with a parenthesis. So you're just reading your inequalities from left, your real number line from left to right, from negative infinity to positive infinity. So if your arrows are going to the left, you know that those values are starting at negative infinity. If your arrow is going out to the right side, then they're headed towards positive infinity. And that's how you do your interval notation for your inequalities. All right.